working, Mrs. Olson. We're back up and running. So, okay. Help me remember what information you mostly were given in order to work in the last section with slope intercept form. What did they make darn sure that you always had, or were at least able to find, in order to be successful in that last section, 4.1? What were you going to say, Nolan? They gave you the y-intercept, or they gave you some form of a point where you could figure out what the y-intercept was very easily, right? Did we ever have to do any calculations to come up with it, or was it always just kind of there? It was just there, right? And then there were times where maybe they gave you 2 points and you might have to calculate the slope, right? Now today what they're going to start doing is they're going to start moving points off of the y-axis. Instead of having something where you know the y-intercept, they might say, all right, pull Desmos here quickly. They might say, well, boy, extremely slow. Extremely slow. Anybody slow today? They might say something like this. You have a point maybe, I don't know, 2, 3. You have a point 2, 3, and then outside maybe the slope is 1/2. Guys, if this is the point that they choose to supply you with and the slope of 1/2, do we know the y-intercept now in this case? If I supply you with this point and the slope, do we know the y-intercept right off the bat this time? Do we know the point on the y-axis at all? We don't. Okay, we're not going to know that right off the information, or right off the start for information. Okay, so really what I'm getting at today is this: we're going to be doing a lot of the same stuff, but this time instead of being given the y-intercept, you are going to have to figure out what it is. Now, fortunately for us, there's some nice formulas in this section that allow us to do that. So if you'll take a look right here in our notes, guys, 4.2 is called point slope form. I'm guessing that maybe you've heard of it in the past. All right, but again, we'll look at some real life applications and start interpreting some of the things that come with it. Question that we want to ask ourselves today is, how can we write an equation of a line when you're given a slope and a point, and that point not necessarily the y-intercept on a line? So I'm going to volunteer to read my first goal for you today. Okay, Mason, go ahead.
Write an equation of a line given slope and a point on line.
Excellent. So we're going to be writing equations again. First of all, what form do you think we're going to end up in? Say it one more time, Kelly. Okay, so our end result, we really want to make sure we get back to this form y equals mx plus b, slope-intercept form. I will tell you, again, our job is to figure out what m is and what b is. Once I know the slope, and once I know the intercept, you satisfied the conditions that they're asking you to look at. Okay. Secondly, they want you to write an equation given 2 points on a line. And then thirdly, we'll use linear equations to solve some real life problems. So, what you really need to know today is this. In our vocabulary, the first thing we have up here is called point slope form. And we say that this is a linear equation of the form, okay, this is very, very important right here. I'm going to highlight this. You might want to circle it, whatever it might be. Okay? Guys, right here, doesn't this y kind of match this y right up here? In my formula for point slope form? All right, but on the left side, instead of just having y, you have y minus 1. y1. Recall that when we've talked about slopes before, we've had a formula for slope that had like y2 and y1 in it. Kind of the same thing. What I want you to know about y1 and x1, I'm going to write this. x1 comma y1 is just a value. It's a point. So as an example, if I had a point maybe like 3, 6 that we're passing through with a certain line, The y and the x will always stay a y and the x, but the y1 and the x1 are numbers that we're substituting in for x and y. So based on that point 3 comma 6, what do you think the y1 value would be? What are you going to throw in for y1? The 3 or the 6? The 6. Okay? Then this is going to equal m being my what, guys? M being my what? Slope. X is just going to stay an x. What do you think the x1 would be if this was my point right here? 3. Okay? Be 3. So what I want to do is I want to tie in example 1 with Desmos. We're going to kind of draw a graph of this here quickly, and we'll see if what we get in the end for an equation matches the graph of the described situation to prove that this formula is going to work for us. And then I think once you see that the formula works, this is going to be pretty easy peasy. You can fill in the blanks. What was it? Lemon squeezy. All right. That's a good word. Easy peasy, lemon squeezy. All right. Volunteer to read example 1 for us. We're using a slope and a point. Volunteer to read example 1. All right, Kaylee, go. All right, what point do you know you have to pass the game? 1 comma 6. Okay, so I'm going to go ahead and I'm going to kind of highlight, decimals. What was the point again? So 1 comma 6, you say? Okay, point's plotted right here, right? And then how about your slope through that? -1/2. Okay, so let me do this quickly. And you don't need to write this down. So it looks like to me down 1 and right 2. Is that correct? Okay, so down 1 and right 2. This would put a point rate. I'm sorry, down 1 and right 2 for a slope of -1/2. Wouldn't that be another point right there? Okay. So guys, quickly, if I draw a line here, I'll do the best. I'll get some good points here. Down 1/2. Down 1/2. Down 1/2. Okay, again, the blue point being my initial point that I started with, slope being -1/2. It appears to me that if I would draw a line here, this is kind of what we get right here. Guys, right in this part right here, what does it appear? We know the slope's -1/2, right? After I've drawn a line for the description they've given us, what does it appear like the y-intercept might be approximately? It doesn't go right through a corner, but what does it appear like it might be approximately up here? Here's 5, 6, this next one would be 7, so it looks like it's right between 6 and 7, so what do you want to call it? 6.5, okay. So we think the equation for this would be what? What was the slope again? So -1/2 times which variable? And then how about an intercept approximation? Okay. Jot that down in your notes somewhere. Jot that down in your notes somewhere. Maybe right at the top of this. We think that's what we're going to get, right? You guys agree with the graph, the drawing, all the information that's been provided? Do you agree that that's a pretty good estimate on a line for this described situation? All agree? Okay. Well, let's go ahead then and take a look at our notes then on example 1 as it relates to this point slope formula. And we'll see if we match. So here we go on this. First of all, what's the point right here, guys, that we're passing through? 1 comma 6. So in point slope form, guys, the implication here is the following. We're going to let x1 be what value? What is the x value of this first point? What's the y value of our first point? Okay. So here comes the formula. Here comes the formula. We can write an equation if we have a slope and an intercept. I'm sorry, if we have a slope and a point using this formula every single time. So let's fill in what we know. So let's roll with this. Here we go. The formula. I'm going to rewrite the formula. Y minus y1 equals m times x minus x1. We're hoping we get a solution in the end that matches what we saw graphically. So let's start filling some stuff in. Here I will start with y minus how much, kiddos? Y minus 6 equals my m value. What is the m value here? How much? You bet. Slope, they told us. It's negative 1/2. So n for m will be negative 1/2. And x minus how much, kiddos? X minus, what's the y1 value? I'm sorry, the x1 value. Yep, thank you. X minus what here? 1. Okay, so I've got stuff filled in into the formula already. Now again, what I would like to do is end up in some kind of slope-intercept form, which means we've got to get y all by itself. So here's what I would tell you to do. First step, I don't want parentheses in here, so we're going to combine some like terms. I'll call this y minus 6 equal to. All right, help me distribute on the right side. We haven't talked about that for a while, so let's refresh our memory on this. Go, Emily.
So I take negative half times x, so
Yep.
negative half x.
Be careful on the second part.
Plus a half.
Plus a half, you bet. Negative 1/2 times negative 1 would be positive 1/2, right? So help me get y alone. What are you going to do next? Add 6 to both sides. Okay. What's left on the... tell me that they just unplugged. What's left on your left side then, kiddos? Y alone. That good or that bad? That good. Okay, you're going to have a negative 1/2 x. What's 6 plus a half going to be? 6.5, 6.5. Oh my goodness. Isn't that what we set out to go after right there when we saw this graphically? Works, doesn't it? Works. The only thing you need to know for this right here is a slope and a what? Point. Slope and a point. So here's the problem. Look at example 2. Look at example 2. I'm going to circle that as that's my solution right here. All of a sudden in this next example, guys, they say write an equation that passes through 2 points. Well, we can't do it because they don't give you what? They don't give you the y-intercept. They're not going to give you the y-intercept anymore, unfortunately. Do they give you the slope? So if they don't give you the slope, you can't do it, right? Right? You can't do it. Are you saying no, you're wrong, Carson? Or you're saying nope, can't do it? No, I'm wrong. I'm never wrong, Mason. Mason, why am I wrong here? Oh, what is that y2 minus y1 thingy? It's a formula for finding slope. Formula for finding slope, right? Yeah, we can do that. So let's do that. First things first, if they don't give you the slope, then do what? Solve for it. You bet. So let's do this. I'm gonna do something here quickly. Okay, so I can see my points. So let's find our slope here in this. Okay, so I'm going to go ahead and start with m in this right here, as those my 2 points would be -2 comma -6 and 6. I'm sorry, 4 comma 6. All right, how about my y2 value, guys, to start up top for changing y? 6 minus what value? on the bottom. Okay. So help me with the arithmetic to find the slope. What do you get up top, kiddos? 12 over 6. And that's nicely going to simplify to what value? 2. So my slope is 2. All right. Well, I'm going to use the x1 and the y1 to plug into our formula now. So to find our equation, I'm going to rewrite the equation of the formula. I should say rewrite the formula. Y minus y1 equals m times x minus x1. So the point we're really choosing to work with right here, that one. Now here's the nice thing about it. I could use the first point, or I could actually use the second point. Okay, makes no difference. Help me fill some stuff in, kids. Y minus, what's going in for y1 based on the point I circled right here? -6. Y minus -6 equals my slope value. What do we find our slope to be? 2 times x minus -2. Okay, I don't like some of this the way it's written, so I'm going to get rid of some signs before we actually distribute in this right here. You guys agree the left side's really y plus 6? You agree the right side's 2 times the quantity x plus 2? Guys buy that? So to distribute on the right, I'd have y plus 6 equals, what's the expression, equivalent expression on the right? 2x plus 4. So in order to put this finally in slope-intercept form, or to represent this in a linear model, subtract 6. So when you subtract 6, what's that going to make the right side look like then? So from here you end up with y equals, awesome guys, awesome job. You understand the formula. You understand why the formula works. We proved graphically that it matched the first formula, right? Okay. I'll wait till everybody has that down before I go to the second side of the notes. You may have questions to this point. Bless you, Emily. Times 3. Really?
I read that means you're gonna.
One.
I don't know, but I read that.
I'm a violent sneezer. It's like a gale force wind when it happens. Anybody need more time with that page right now? Anyone? Okay, let's look at the second page of your notes. We'll get this finished up today.
Yeah.
So guys, all of a sudden we're back into this idea of linear functions, but you guys know how to handle linear functions to begin with. Guys, when I say right here, when we want to write a linear function f with the given values, what does this f of 8 equal -1 imply? If I see f of 8 equals -1, what point is that? Right here, gang, how would you denote this as a point? Say it again, Nolan. So I have a point, 8 comma -1. There's my point 1. Yep. That's how you turn function notation into ordered pairs. What's this over here, kiddos? What's this over here? XY form. 6 comma 0. Hey! Y-intercept is 6, right? Because there's a 0 up there. 6 comma 0 is, you say no, Tori? Why can't I use 6? There's a 0 up there. Six is an x value, okay? That would be the x-intercept, not the y-intercept. Oh, darn. You're going to have to work at it. All right, here we go. Let's find the slope, kiddos. What minus what up top? I'm done talking. Raise your hand. Tell me what to do. Say it again. 0 minus what?
Oh, 0 minus negative 1.
There you go. How about on the bottom?
It'd be 6 minus.
6 minus 8. Okay, so up top I have 1. On the bottom I have negative 2. 1 over negative 2, so what's my slope then? Negative 1/2, right? Slope's negative 1/2. All right, so let's go. Here we go. Plug it into the formula. Y minus y1. So y minus what first, guys? Which is? All right, let me make some room here so I can squeeze this in here first. All right, so here we go. What did you say? Y minus how much? Equals my slope of negative 1/2 times, here we go, x minus x1, which is 8. Okay, on the left side, this is y plus 1. This will equal negative 1/2 x plus 4 when you distribute. Tell me what this is going to look like finally in slope-intercept form, kiddos. Where do you guys end up with a solution? Negative 1/2 x plus 3. Perfect. There it is. There it is. Just show hands. I'm like, yeah, this is all right. This is all right. Okay, roll. Solving a problem then. Look at this right here. Where would I apply something like this? Okay. I'll read this aloud. You guys follow along with me. It says to ride in a best-in-town taxi, you pay a start fee and a mileage fee. It says table shows a total cost of taxi ride for different distances. It says, can this situation first of all be modeled by a linear equation? Ooh. Can we model that by a linear equation, yes or no? How do we determine if the table is linear or not? What have we done in the past? Her proportions, making sure that ratios are equal. That's what that definition would be. Tori, you were saying change in y over change in x. All the change in y over change in x are equivalent. Okay, so let's check it. I'm just going to do it this way here, guys. Change from 13 up to 23, what is it? 10. What's the change from 4 up to 8? 4, isn't it? 23 to 28, what's that change? Change from 23 to 28, what's that change? 5, right? Change from 8 to 10 is 2. And then change from 8 to 33, I'm sorry, 28 to 33 is 5. Change from 10 to 12 is 5. Okay, so my change in y over change in x ratios. Ah, yeah, thanks. So like this, right? All right, my mistake, thank you. So the first change in y over change in x I have is 10 over 4. Second one's 5 over 2. Well, they don't match. Not linear, right? Wrong again? Where am I wrong? 10 over 4 would reduce to what? 5 over 2. So first of all, is this linear? Why? Linear because we have a constant. We have a constant ratio. Okay, so here's the deal. We want to model this right here. It says if it is linear, which we've just shown that it is it possible to write a linear model that represents a cost as a function of the number of miles? You bet it is. Now again, guys, if you didn't catch on to the constant rate idea, and I've said this before, and I'll say it over and over again, what's one place to turn to? Maybe look at it visually. Yeah, decimals. Okay, so let's go on this. Do we have a slope at all, guys? Do we know the slope at all? Not yet, but I'm going to tell you this right now. Actually, you kind of do. When you talk about rate of change or constant ratios, we've said rate of change in the past is always the same slope. So we had the 10 over 4. Isn't that a change in y right here, 10? Isn't that a change in x, 4? So 10 divided by 4 will get you a slope. All those constant changes are just a slope. So somebody punch this up. What is 5 divided by 2 or 10 divided by 4? Well, we should know it's 5 divided by 2 or 10 divided by 4. 2 point what?
5.
Slope's 2.5. Slope's 2.5. Okay, so let's get an equation for this situation. Y minus y1. Well, my first point's 4, 13, isn't it? So what's the y1 value I can choose to throw in there? 13, good. That's going to equal my slope of what value? Times the quantity of x minus my x1. 4. Make this as quick as possible. Calls y minus 13 equals 2.5x minus 10 when you distribute. What do you have to add to both sides? All right, so when I add 13 to both sides, here's what we end up with. We end up with y equals 2.5x plus 3 when I do that. Okay? Y equals 2.5x plus 3. So guys, whatever this taxi cab service is right here, the second you jump in that taxi, you've already decided you owe him how much money. You start $3, right? And then for each mile you travel with him, how much is he adding per mile? $2.5. So monetarily, that would be $2.50. Okay? So could you figure out what a cost would be if you rode 26 miles with this guy? Yeah. Just throw 26 in for X, right? Okay. First things first. Do you understand the formula?
Yeah.
Okay. Any questions about this? Yep. All right. I'm going to go ahead and stop recording here, and I'm not going to give you a quick